And when it goes like that, you go, oh, okay, then that's about right. But then you wind it.
I don't like the word sustainable. I'd rather the word be growing. Sustainable is just keeping it to what it is. It really should be getting better rather than let's just keep it at that level.
Understanding if fish populations are going up or down is an important part of successfully managing a fishery. The example fishery that we're going to look at is barramundi in a billabong, and we'll use it to demonstrate how different factors affect the population. A unit of measurement of the size of fish populations is biomass. Biomass is the weight of the population. In nature, the biomass of a fish population is limited by the environment. When environmental conditions are good, fish populations will be bigger, and when they are bad, they will be smaller. So, for example, in our billabong, if the water dries out a bit, then the fish population that the billabong can sustain will go down. There are many factors that influence population biomass. The main factors, though, are recruitment, growth, immigration, emigration, natural mortality and fishing mortality. It's the relative strength of each of these factors that determines if fish population biomass goes up or down. Recruitment, growth and emigration will act to increase fish populations, whereas emigration, natural mortality and fishing mortality will act to reduce fish populations. Fisheries scientists aim to measure these factors to better understand changes in biomass. Traditional owners have always monitored fish populations, but in different ways and through connection to country.
When we're fishing, we get to understand the population in the particular waterholes that we fish, and sometimes we'll catch some really big female barramundis and often we'll release them. Other times, other years, we don't catch very many at all. We might catch some of the smaller sized barramundis and attendee.
Fisheries scientists don't have the same connection to country as traditional owners, who have gained knowledge of their local waterways over tens of thousands of years. Instead, scientists rely on measuring the factors which then inform the population assessment. Let's take a closer look at each of the factors and how they affect population biomass. Recruitment is the number of small fish that survive and are available to be caught. Recruitment varies depending on the species of fish, environmental conditions and the number and size of breeding individuals. So for example, in our billabong, a single barramundi is capable of producing more than 10 million eggs. In a good season where there are a lot of breeders and conditions are right, recruitment will be high and population biomass will go up.
So when we see those fingerlings, for me, I get very happy to see them because it tells me that those big females are producing productive eggs to get the fingerlings. There's a lot of predators in the water these days. This is called eating the fat off the country.
Fish growth is the next factor that affects biomass, and it varies from species to species. Returning to our billabong, barramundi go through a range of growth stages to reach adulthood.
We have 3 categories for the different sized barramundi. Attendee, which is the little ones. Amadi, which is 75 centimetre ones when they're still males. When they change from male to female, and then we call it a mulwood.
At each stage, the barramundi are getting larger and heavier, which adds to the biomass of our billabong fish population. The next factor to look at is immigration.
In the river, there's like families or groups of blackfish in the river, which are a different colour. They're a resident blackfish, and they're sort of like the family groups all through the river system. But then you go and get what we call the travellers, or the silver bronze blackfish, which run up the coast. And then they go into spawn, and when they go in, there's hundreds, thousands of these fish which come in. So what we do is we target them, and there's a definite cycle in that, and that's like, when the wattle comes out, that type of thing. We know that these bronze fish are coming up the coast, and they're getting ready to come into the rivers.
This is an example of seasonal immigration, where fish move from ocean waters into rivers to breed. The result is that the biomass of the local fish population in the river increases during this period. In our billabong, immigration into the fish population can happen as a result of the rainy season connecting the billabong with the river. Small males can enter the billabong during this time, which will increase the biomass of the fish population. The opposite of immigration is emigration, and it is the movement of fish out of the fish population. Emigration is the first factor in our list that reduces biomass. Again, in our billabong example, this can happen when large mature fish leave the billabong to spawn in the river mouths. The eel populations in Lake Condor also experience a mass emigration of adults each year, which reduces eel biomass.
Short-finned eels, from what we know with their life cycle, they catadromous, so they spawn out at sea, but they spend most of their lives in fresh water. Here, about Easter time, is the mob have the eel run, or when all the mature eels, so they mature between 15 and 20 years. Around Easter time, they'll take off out to sea, all the mature ones, and when they get to the estuary, if it's closed by a sandbar, there'll just be thousands of them just collecting there, and mob will go pick them off and stuff like that, and they'll wait for the sandbar to open, and they'll take off out to sea.
In many fish populations, the factor that has most effect on reducing biomass is natural mortality. There are many causes of natural mortality, some of which are old age, predation, starvation, disease and environmental stress. In our billabong up north, one source of natural mortality on barramundi is predation by crocodiles. Obviously, an increase in the number of crocodiles in our billabong will have a resultant effect on the fish population. So far, all the factors we have looked at are natural processes. The final factor on our list is fishing mortality, the death of fish in a population due to fishing. As fishers remove barramundi from the billabong, they are reducing the population biomass. Remove too many fish, particularly breeding age fish, and the population may struggle to recover. This is called overfishing. However, if the level of fishing effort is managed properly, then we can catch a lot of fish but still maintain a sustainable and productive population.
The way we look at it, if I go, say for example, flathead fishing, I'll fish that area, I'll get, I might get my 20, 30, 40, 50 flathead out of that area over a period of time, but then I'll leave it and then I'll go somewhere else. But I know that that's there and I'll come back to that in 12 months' time.
We've now covered the main factors that affect fish populations. As you can see, some factors, including recruitment, growth and immigration, act to increase population biomass, whereas emigration, natural mortality and fishing mortality act to decrease population biomass. It's the balance of these variables that determines if the population is going up or down. Fishing mortality is the one factor that can be modified by fisheries managers to adjust population biomass. In our next video, we'll look at the processes managers use to monitor, assess and regulate fishing mortality.